Great. Now we're now talking about graphing trig functions, but let's take a step back and talk about some of the things that we've already talked about this year, and let's look at a quadratic here. So when I look at this quadratic, it tells me a few things just from the equation. It tells me that I've got the quadratic, the parent function here. It tells me that I've got a vertical shift of whatever that number is out of the k. It tells me that I've got a horizontal shift here with whatever that value is with the h, and it's the opposite of what I think would happen. It also tells me that I've got a stretch and a shrink, and we didn't do much with the stretch and shrink part, but it happens there, and it's going to happen in our trig functions too. Okay, if I put a number out in front of those things, in front of the whole equation or just in front of the x, it causes some stretching and shrinking. In terms of the trig functions, we're talking about amplitudes and periods, the things that are changing. There's also a few other things that helped us graph these. It helped us to find the y-intercept, the x-intercept, and the vertex. Those were all things that were nice for us to be able to find when we were going through in order to make this a better graph. But we can do a nice sketch with just the parent function, horizontal shift, vertical shift, and any stretching and shrinking that happens. Okay, that allowed us to get a pretty decent sketch of what we were doing. And so that's really what we're going to end up doing here when we're talking about graphs of sine and cosine functions. Okay, we're talking about the amplitude, a stretch in a vertical direction, a period, or I guess it could be a shrink if that was like a 1/4. The period, we're talking about a stretch or a shrink in terms of the going along the x-axis in a horizontal direction. We have some vertical shift ideas. If I add something on the outside, it's a shift up, just like it was before. If I add something on the inside, it's a shift to the left. But the problem is that if I put a number in front of that x, I have to do some extra work to it. And so we're going to start just right off the bat saying that you want to find where does this graph start and where does it end. So we want to find these four things in order to go through and make a good sketch of this graph. There's a couple other things that we probably could throw in here that allow us to make it a really good sketch, but this will give us a pretty good basis of a nice graph for these trig functions. And when we apply these transformations, we want to do them in this order. We want to do the vertical shift first, then we want to figure out the amplitude from there. We want to do the period, so find out how long it's going to be, and then we want to do any horizontal shifting after that. So that's the order that you want to go in. And so let's take a look at the first example here. I'll fill this one in kind of as we're going along, and we'll do this one together, and then the next couple I'll fill in the information, and then we'll make this video a little bit shorter. So I've got y equals sine x minus pi over 4. So I'm looking for the amplitude. That's the absolute value of the number in front. Well, the number in front is a 1, so the absolute value of 1 is a 1, the amplitude. The period is 2 pi divided by b. And so I have 2 pi divided by the number in front of the x, or the theta, whichever value symbol we're using for that. And so I've got a 1 there as well. And so this goes in 2 pi. Okay, perfect. I've got a look at a vertical shift here. Vertical shift is adding or subtracting on the outside of the equation. There's nothing that is out here. There's nothing there, so there is no vertical shift. This doesn't happen. And the last part is a horizontal shift. And when I look at that horizontal shift, I'm moving this pi over 4. Okay, and so I could think of it that way, that all I'm doing is I'm shifting this pi over 4, and it's a negative on the inside, which means that I'm actually moving this whole graph pi over 4 to the right. But it allows me to have more of a systematic approach. If I take that inside part, the 1x minus pi over 4, and set it equal to 0 to find my starting point, and if I do that, I add pi over 4 to both sides, and I get x equals pi over 4. That's my starting point. And then I can go and I continue this, and I can take my x minus pi over 4 and set it equal to 2 pi. I just did the 0, 1. And set it equal to 2 pi. And add pi over 4 to that. So if I do 2 pi plus pi over 4, I want to get a common denominator there. So the common denominator is 4, so this is going to be 8 pi over 4 plus 1 pi over 4 is 9 pi over 4. It's just 1 pi over 4 past 2 pi. Okay. And so that ends up looking like this. So I want to do them in this order, vertical shift. Well, there wasn't any. Okay, so there's no vertical shift in this. Then I want to do the amplitude. Well, the amplitude is a 1, so I go down 1 and up 1. It's best if you try to make those so that they match up, so that your graph looks like it actually goes the same amount above the graph as it does below. Then I want to start looking at the period. The period is 2 pi. And so I've got a period of 2 pi, so my graph should make one complete frequency, one complete revolution in that 2 pi. But because I chose to do my horizontal shift in the way that I have a starting point, and this was the ending point, by the way, where I have a starting point and an ending point, I can plug those in. So I've got x equals pi over 4 as my starting point. That's where the sine graph starts. So sine starts at the x-axis. And I can then say, well, out here at 9 pi over 4 is where this is going to end. So here's 9 pi over 4 out here, and this is going to end here. Okay, so I've taken that, the graph, the original one looks like this. The original one starts here and goes up at pi over 2, goes here, and then at pi goes there, and then comes back down, and at 2 pi ends here. But I've taken each one of those points and I've shifted them pi over 4 to the right. Okay, so I'm taking that original blue graph and I'm moving everything to the right. And maybe a better way for me to look at this would be to actually put those points in. So I've got a 0 here, pi over 2 is here. This is at pi. This is at 3 pi over 2. And this is at 2 pi. So I'm taking each of those things and I'm moving them pi over 4 to the right. Well, the 0 moved over pi over 4 gets me here at pi over 4, the starting point of this graph. If I take the pi over 2 and I move it over pi over 4, I have to start moving into some different fraction things that happen, and as I'm thinking about it, that might end up being a little bit more confusing for us. So I'll take a look at just this in red. Let me get rid of the blue numbers here. But the basic idea is that I'm taking this whole graph and I'm shifting it to the right, pi over 4. Okay, so the blue graph becomes the red graph by shifting it to the right. So let's continue with the red one. We want to find halfway in between 9 pi over 4 and pi over 4. Well, again, I can find halfway in between there by doing 9 pi over 4 plus pi over 4 and then dividing that by 2. So I get 10 pi over 4. And when I divide that by 2, I actually need to multiply that by 1/2. Multiplying by 1/2 and dividing by 2 are the same thing. Flip over the fraction. And so I get 10 pi over 8. Which reduces, 2 goes into both of those, so I get 5 pi over 4. So halfway between these two is 5 pi over 4. And this distance right here is just a pi over 4. So my original was at pi, this original blue one was at pi, and I shifted it 1 pi over 4 to the right. Okay, so that distance right there is just a pi over 4. I'm just moving it to the right. But again, for some of you that might be a little bit more confusing than just plugging in these points. So here's a 5 pi over 4 that then is halfway in between the pi over 4 and 9 pi over 4. I want my other 2 points in between, and we can label them. We can label those if you wanted to, again by doing taking pi over 4 plus 5 pi over 4, and then setting that adding those together and then dividing by 2, finding the average between them. But I think that, well, what we want to do is we want to be looking at the sketch here. And so this blue graph is just moving to the right pi over 4, and it's going to end up looking like this. The things that I want you to be aware of, things that I want labeled on here, the beginning points, the ending points, the middle in between them, because I want you to be able to find that middle point. Okay, so beginning point, ending point, and the middle in between. If you wanted to go through and label these other 2 sections in between the beginning and the middle and the end, that would be fine, but you don't necessarily have to for what we're trying to get out of these graphs. Okay, so let's take a look at the second one here. I'm going to take and fill in this information, so if you don't want the answers to this, if you want to try it yourself and then see what happens, do that. Stop the video right now, because I'm going to fill in everything, and it's going to show up in about 5 seconds. So here's the amplitude is the number in front. That's a 3. The period is 2 pi. The vertical shift is up 2 because I've got the plus 2 on the outside, and the horizontal shift, there isn't one. Okay, so I'm not moving this left or right at all. But I am moving it up 2, so I want to apply these things in the correct order. The first order of this is the vertical shift. So I want to move this up 2 to begin with. So I'm going to draw this line in here because this is going to be my new x-axis. That's where everything's going to happen. That's where the graph's going to cross. It's no longer going to necessarily cross at the x-axis down below. Okay? But I have an amplitude of 3. So an amplitude of 3 means that from that new value that I've moved this up to, the graph is going to go up 3 from that. And it's also going to go down 1, 2, 3 from that. Okay? So I've got an amplitude that moves this up 3 and down 3. Then I've got a period of 2 pi with no horizontal shifts. Well, when we look at that, we've got 2 pi over here and 0 as the starting point. We have a cosine graph. So the cosine graph starts at the top of the revolution at 0 and ends at the top at the end of its period. Now I've got all of the normal things in between here because I haven't done anything to shift it. And so I've got pi over 2 pi, 3 pi over 2, and 2 pi. At each one of those values, I'm at a different point on this graph. So the graph is going to go down, and it's going to cross where I shifted it up at pi over 2. Then it's going to continue down, and at the next point, it's going to be at the bottom of its amplitude. At the next point, it's going to be back up here at the graph where I've shifted it up, and it's going to end at the top there. So I end up with this graph that looks like this. Now let's think back to what the original one looked like. The original one looked like this. It went up 1 and started up 1, went across the x-axis, went down 1, went across the x-axis, and ended up 1. So the original graph looked like this in terms of the cosine graph. So I took that cosine graph, I moved it up, so each one of those points moved up, but then I also elongated the y value, so I changed that amplitude to be a lot steeper, or a lot higher. So I want to reflect that in my graph, and it's pretty well reflected here. You can see that this graph is pretty long. in terms of the original one, and follows the same general guidelines, but it's shifted up 2. Okay, so keep that in mind as you're going along here, that your sketches should match ideas that we're looking at in terms of these transformations. So here's the next one. Kind of it involves a lot of stuff, but we'll take it step by step. And if you don't want the answers, if you want to run through the answers, you should stop the video right now, because I will give you the answers before I graph it here. I'm actually going to stop this video, and we'll start up on the next one. If there's 2 examples left, and so I'll put those 2 examples on the